Okay, good morning again. Then now we can start the lecture. Thank you, Chamath, that calling there and making me host.
Sorry for delay, sir.
No, it's okay. It's okay. I think, Chamath, that hereafter that we have to have some kind of additional classes also. I'll make two links there. Uh, then for weekend group and weekday groups, and I'll send both links to you. Then you can share those links with your batchmates.
Okay,
Then
sir.
without having any problem and delays that hereafter we can start the lecture. Okay, I'll send those links to you.
Okay, sir.
Okay, thank you, Jamaat. Okay, then these are the things that yesterday we discussed. And at the end, with diode applications, we discuss how can we use diode as a switch. You know that diode is having two modes there, the reverse bias mode and forward bias mode. The reverse bias mode diode is, we can consider diode is switched off. The forward bias mode, we can consider diode is switched on. Okay. Then with the forward bias mode, diode can conduct. The reverse bias mode, diode is not conducting. There's the summary. Okay. And when we forward bias the diode, if it is silicon diode, we have 0.7 volts voltage drop across the diode. And if it is germanium, it may be 0.3 volts. Okay. And after that, finally, we discuss about these waveforms. And again, we have some kind of calculation. Then after deducting 0.7 volts from the input voltage, we can find the output voltage of the diode. And across the resistor, we can see 5.3 volts there. The same thing for this one also. We have voltage drop across the diode. This is the diode voltage across this one. And this is resistor voltage. Okay. Then you know that here V in equals Vf plus Vr. Then based on that, we can draw these waveforms. All these waveforms are small amount less than input voltage. If it is the value is input value is there, you can deduct 0.7 volts and you can draw the output voltage. And if it is not shown the values, that you can slightly decrease in small amount, you can draw the graph like this. Okay. The second diode application, we can start from this last figure. Here you can see the input voltage is having both positive side and negative side. It's a sine wave. But the resultant waveform across the resistor and from the diode, we cannot see all these positive and negative sides there. Why? The positive half cycle, we know that diode can be forward biased, then diode can conduct. Then as a result, 0.7 volts less input voltage, that type of voltage we can receive from the output end of the diode. Then across the resistor, we have this red color one. But in this negative half cycle, diode will be reverse biased. Then no output will come through the diode. Then across the resistor, we don't have any voltage. Then across the resistor, then voltage is zero. Okay, again, that for positive cycles, we have the output. For negative cycles, we don't have output. So that is our next application. Okay, you can see here all the positive half cycle have come, but these negative half cycles, they don't come to the out. Then if you apply this type of waveform to diode, okay, from the output side, we can see only positive half cycles like this. Okay, you can see this, and here we have applied this one. You can see this is AC voltage. Why? We have all positive cycles and negative cycles, but the resultant one, we have only positive. Here we have the voltage is going across the zero line. This is a zero voltage line. And this is voltage. Okay, and we have this one only. Then what is this? This is a DC voltage. Then here we have AC to DC conversion. Okay, AC to DC conversion means this is rectification. The second application of the diodes, rectification. But when it comes to rectification, you can see here, when we apply the whole waveform, having both positive cycles and negative cycles and all these things, the resultant waveform is containing only positive cycles. Then, because of that, we say this is half wave rectification. Okay. This is half wave rectification. Actual diagrams, if we draw actual diagrams like that, for example, then why do we need this rectification? That normally, you know, that our commercial supply, commercial supply coming from CEB. Then we have 230 volt AC voltage we are receiving at our homes from the outside. Okay, but this voltage is a huge voltage. One is this is huge voltage. The other one is this is AC. Okay. First point is this is high voltage. Okay. Second point, this is AC one. But when you consider the normal electronic devices, for example, if you consider, for example, your mobile phone, your laptop, or whatever the electronic devices, they don't work with this much of higher AC voltages. They need low DC voltages. For example, your mobile phone, if it is a USB charger, it's most of the mobile phones, okay. Now, previous mobile phones may have the different voltages, but most of the mobile phones, then they have 5 volts and some amount of current, 5 volt DC supply they need. And most of the laptops, they need 19 volts DC. I'm not going to talk about the current requirement here. The voltage requirement is this, but all these things, what you can see here is they are DC. Okay, and see this voltage is low voltage than 230, and the other this is DC voltage. Then we need this AC to DC conversion. to work with our electronic circuits. Okay, then low voltage, and how can we lower the voltage? There are certain methods to reduce the voltage. One popular method is we can have a transformer. Okay, we have a transformer. It's a primary coil, primary side. It's having 230 volt AC or something like that. This is primary coil. The secondary coil, we don't have much more turns there. This is secondary side. Sometimes this may be 6 volt AC. Then this transformer. This one, this transformer is step down transformer. This step down transformers reduce this for higher voltage to a low voltage. Okay. And after that, from this side, then here we can apply higher voltage like this. And from this side, we'll receive small AC voltage. But still you can see from the input side here, this is AC waveform, and output side also AC waveform. But what we have done, we have reduced the input voltage. Now the higher voltages have been reduced to low voltages, but still AC part is there. Now we have to convert this AC into DC. Then what we are going to do, then we can apply a diode here, and we can put our load. For the load, we can draw a resistor. Otherwise, this resistor can be replaced by any electronic device, any electronic module or whatever the thing. But for the moment, we can draw a resistor and this diode. You know that after this one, in this side, we have this type of waveforms and this negative half cycle. The diode has cut those negative half cycle. It's not coming to this side, then across the resistor, and this is the waveform we are having. Then when you consider from this point onwards, this one, this side is this AC to DC rectification is done by this diode. Then when you consider these two input points from this AB input points, this side, if you take this is point A and this is point B, and here we have given AC voltage input. Because why I have drawn this second diagram, the below diagram here. Here for the voltage reduction, we have used this step down transform. But it doesn't mean all the time we need the step down transformer to have this voltage reduction. And whatever the way, anyone can do this reduction. And after that, this circuit block can be used for this AC-DC conversion, that is rectification. And this half wave rectification can be done by this circuit. Then any AC voltage input can be given here. It is necessarily not come from transform, but transformer is one of the sources which can provide this low voltages, low AC voltages here. But any voltage source is there. maybe power supply or whatever the way. It doesn't matter. We need here this AC voltage input only. And for this AC voltage, you can see here, and here we have the large voltage input on this one. And up to this point, the transformer is doing this part. But it does not belong to this one. The AC-DC rectification, we don't want that part. But to have a practical idea, to have the practical application, I have included this transformer. Then you can identify, you can have some kind of idea about how we can receive this low DC voltages from commercial available power supply. And all our household voltage outlets from the plug, you can see this 230 volt AC output voltage is coming. Then we have to have idea that how can we reduce this voltage. Then using this step down transformer, we can do it. Okay. After that, still we have AC voltages. Then using this small circuit setup, using single diode, you can do this one, but these voltages are still not good for electronic devices, but for the resistor, it doesn't matter. Why I'm telling that these voltages are not good for electronic devices? Because electronic devices they are very sensitive devices. Then if you provide this type of voltages to electronic devices, most of the devices may not work, and sometimes some of these devices may be damaged. Okay. But anyway, here we have this AC to DC rectification, AC to DC conversion here. And this one, this is AC, and this is DC. Its conversion is there. Or we will come to that one. How can we smooth these voltages? That is our next step. Until that, you can see this AC to DC conversion is there. And what we have done to do that one, only single diode. Okay. Any question? Anything? Okay. Then shall we discuss? And here we have discussed about that half wave rectification. Then there should be full wave rectification. Okay. How can we do with this full wave rectification? Okay, here one question is asked to explain the transformer part again. Actually, this transformer, what this transformer does is that this, because of this transformer, is step down transformer. Here we have primary coil. This side is primary side. This is primary coil, and this is secondary coil. This primary coil is having much more turns to hold this 230 volt, but that type of higher voltages. And the secondary side, we have less number of turns there. And here we have smooth metal medium. And through this smooth metal medium and with the magnetic characteristics, this voltages will be reduced. The other side, okay. Then anyway, that I'm not going to discuss the transformer operation, but transformer can do that voltage reduction if it is step down transformer. Then when you consider step up transformers, the input voltage is low voltage, the output voltage will be high voltage. But in this case, if it is step down transformer, the output voltage is low than input voltage. And here we have used step down transformer. Then from this transformer, when you input this 230 volt, this much of higher voltage, the resultant output voltage may be lower. It's necessarily not to have 6 volts, it may be 12 volts, 3 volts, 24 volts, 48 volts, like that. The output voltage, the secondary side output voltage can be varied depending on the transformer design. Okay, in this case, I have you put this figure to show you that the voltages comparatively, you can see that input voltage and output voltage is a very, very low voltage compared to input voltage. And up to this point, the transformer has done this voltage reduction. Now we have step down transformer, it has done this voltage reduction. After that, here we have this small AC waveform, that is the input waveform of our the simple circuit. And when you give this simple voltage here, the AC voltage here, when you send this one through the diode, from the output of the diode, at the other side of the diode and the resistor side, we have only this positive half cycles. Why? The positive half cycles can forward bias diode, then through that part, diode will be forward biased, and then positive voltages can go to the other side of the diode. This makes it okay. Then this is, but anyhow, that it is not necessarily all the time to have transformer. Anyway, the different people can have the different solutions. Then you have to apply AC voltage to this one, and this is our AC to DC rectification part. And here, I think I couldn't mention this one, and this rectification, that here this diode, the simple diode, this one, it has done this AC to DC rectification. And here, up to this point, we say this is the diode, but still this is diode. But in this application, we say this is a rectifier. Okay. And diode can have a different name here. This is rectifier. Based on the job it's doing, then we can say this diode is a rectifier. This diode is having different application. In this application, we can give a different name to this diode. It's a rectifier. Someone can say the rectifier diode. Doesn't matter. Okay, now for the full wave rectification and what we are going to do, and the same setup we can use. Then here we have this transformer one. Remember that it is not necessary to have all the time transformers, but we use this transformer to show you that how we can reduce the voltages. This is 230 volt AC, and this side we have the less voltages. We say VAC, and you can have a different arrangement here. And we use 4 diodes there. Okay, then then we can take output from this point and from this point. Now we have this resistor connected to the output. Here we have used 4 diodes. Then we say this is a diode bridge. Four diodes are there. And you can see here the connections we have given to these 4 diodes. And after making this one, we can say this is diode bridge. This is diode bridge. Okay. Then here we have these voltages as we mentioned this one, the large voltages we have given to the input side, and from the resultant side, this one. Secondary side, we have these low voltages. And let's try to understand then what will happen after having this one. Okay. Then when we have this, especially this positive cycle, this one, the positive half cycle, you can see with respect to this terminal, okay, we can have this points. This is point A and this is point B. And actually, this is the one which will do this full wave rectification part. And to these points A and B, we can input any AC voltage. Then from point A, with respect to point B, you can see at point A, we have positive voltage. Okay, this positive voltage can come here. Okay, this positive voltage can come here. And when this voltage comes to this point, it can see this diode. Through this diode, it can go to the other side. But this one will be reverse biased. D4 will be reverse biased, but D1 will be forward biased. Because of that, it can go through D4. And then when it comes to this point, there are 2 paths, but through D2, it will be reverse biased. Then there is not possible to go through D2. Then it has to go through R. And through R, it will come here. And after coming to this point, again, it has to go to point B. Actually, the voltage is coming this way. Then voltage should go from point A to point B. To complete the cycle, it should go from point A to point B. Then when the voltage sees this path, it goes through D1, forward biasing this D1, and coming through R. And when it comes to this point, then it sees that to go to point B, through D3, it can go to point. Okay. Then this is the way we can find in this positive cycle. It can go through this one and through this. It can come up here, and after that, it can go like this. Across the resistor, current can go this way and here, this direction. Then during this positive half cycle, D1, D3 diodes will be forward bias. Okay. During this positive half cycle, D1 and D3 will be forward biased. Okay. Then D2 and D4, they are not conducting. Okay, then because of that, you can see this side this positive half cycle has come to this side. Okay. Then what about this negative half cycle? Okay. Then this negative half cycle, which color we can use? This negative half cycle, this one. What will happen? But this negative, you can understand this one with respect to this point B. At A, here we have positive voltage. Now the voltage has been created the other way, the other direction. Then with respect to point A, during the negative half cycle, with respect to point A, point B is positive. Okay. Then we can see from point B, here we have positive voltage. Then the positive voltage created at point B, it should go to the point A. Then we can find path how this voltage can go there. Okay. Then starting from this point, starting from point B, this side, it can come to this point, it can come to this junction. Then it can see D2 diode can be forward bias, D3 is reverse bias. Then it goes through this D2 diode. And here after coming to this junction, there's D1 and D2 diodes are there. Through D1, it cannot go to point A, but then it should go through resistor R. And it's coming back to this junction. After coming this junction, to go to point A, it can select D4. Through D4, it can go to point A. Okay. And this is the way it's going through D2, through R, and through D4, it's coming to point A. Then during the negative half cycle, during negative half cycles, the D2 and D4 diodes will be forward biased. And here you can see this one, D2 and D4 here, they are reverse biased. And this one, D1 and D3, they are reverse biased. And as a result, you can see all the time through resistor, voltage is creating one side, one direction, and current is going one direction. Then you can see this positive half cycle, this negative half cycle also come to this way. But when I put minus sign, that don't have a confusion. This side, all the voltages are the positive. It's positive, but due to this negative half cycle, we have positive half cycle at the output. Okay. Then this will continue like this. Now, what can we see? With compared to previous one, the previous one with this half wave rectification, we have received only positive half cycles. But in this case, we have received negative half cycle also to the output side. Then a resultant one is having only positive side cycle. Then it's much better than previous one. We can go back to see the waveforms we had in this half wave rectification. It's one cycle is missing. You can see it's from 0 to certain positive voltage is here. Then after that, it's coming back to 0, and certain period there is no voltage. And after that, again we have another half cycle. But in this case, we have 0 points, but there is no blank period. Okay. With compared to half wave rectification, the full wave rectification is much better. And when we consider this half cycles, this positive half cycle, and when you consider positive half cycle with respect to point B, A is having positive voltage. And when you consider negative half cycle with respect to point B, A is having negative voltage. You have to understand this one well. This means also that when you consider point B with respect to point B, positive half cycle, A is having positive voltage. With respect to voltage at the same time, during the negative half cycle, A is having negative half cycle. But when you consider during the negative half cycle, when you consider point A with respect to point A, B is having positive voltage. That's why we can see this arrangement. During the negative half cycle, from point A, nothing is coming to the output side. Only from point B, voltage is coming to the output. Is it okay? Okay, now from this both half wave and full rectification methods, we have only positive voltages at the output side, this one or this one. And this case also you can have this diode bridge here. And these are the points. And this is the output side, and this is the input side. Here you can give AC voltage input. Then from this can have the same notation, then D3, D4. And this is the full wave rectification circuit. Okay. It should not necessarily include this transformer. And if you want to draw the full wave rectification circuit, this is the one. And you can mention to point A and B, we have to input AC voltage. Okay. Same for this one also. This is the half wave rectification circuit to point A and B. This is the AC input voltage will be there. Simply in some circuits that you can see without drawing this bridge. The bridge is showing like this. And this is the positive terminal. Voltage is coming out, and this is the negative terminal. And these are the two input points. This symbol shows that the bridge is there inside. And normally, top and bottom terminals are the input terminals, and the diodes show the direction. And when you have the diode in this direction, this is the positive terminal, and this is the negative terminal. And these are the AC voltage input terminals. Okay. Now we can have small exercise that if you don't have any problem with this ICO, half wave or full wave rectification, you can try that. Assume that these type of waveforms you are having. What about that if you give this type of voltage? Can you draw the output waveforms? These voltages you can give to both half wave and full wave rectification circuits, and let's draw the output for these things. And this one for half wave, and draw the voltage output waveform for full wave here. This is for half wave. This is for full wave. Just draw this one, and after that we can try another two after completing this one. Take a couple of minutes and try to complete this. Okay, here we can draw these ones. With that half-wave rectifier, you know that only it gives positive cycles, then this positive cycle will be received, and this period it gives 0 voltage. During this time, we have again this positive cycle. But when it comes to this Fourier rectification, then both cycles will be present, but it's not in negative side. All cycles will be in positive side. In this case also, for the half-wave rectification, usually you can see the positive part is there, but during the negative half cycle, during the negative cycle, we don't have anything. And again, for the positive side, we have this. But what about the full wave rectifier? The positive voltage is there. And after that, if we assume that this both voltages, maybe this is plus V and minus V. If we have the same thing, same voltages here, and this one also has come to the positive side, like this. Is it okay? Any question? Then let's try to understand this one also. Shall we try these two? Okay, shall we draw this one with the half-wave rectification? There is no problem because this waveform is in positive side, then there is no problem whether it's half wave or full wave all the time. We have this waveform in this side. Like this. And for both ones, the same thing will be there. But what about this one? Okay, for half wave one, sorry. So, for this half wave one, then whatever the thing that we have in positive side will be there. And during this part, there is no output voltage, but after that, here we have output voltage. With full wave rectifier, the positive side is also there, like this. Then after that, this part is also there, this, and this one. And after that, we have this voltage. Okay. Is it okay? Any question? Okay, if you don't have any question from these parts, then again we can go back to what we have done at this full wave rectification and half wave rectification. You can see this one, this half wave rectification. We have converted this AC to DC. Here also we have this AC to DC conversion. Say, with this full wave rectification, we have 100% both waveforms in positive side, but here 50% reduction is there. Okay, but anyway, that in both cases you can see the voltage is not a fixed voltage, it's varying from 0 to maximum positive voltage, and those voltages are not good for electronic circuits. Then we have to have a different arrangement to smooth this voltage. Okay, then we take this one here. I think what we can do for this one is we can add special component here. It's a capacitor. Okay, then this is the input waveform. Okay, then we can draw the previous output waveform. From the full wave rectifier, but actually, according to the what do we expect from this one? Actually, what do we expect from these positive cycles should be there. Like this, and here you don't have anything from this part. Again, after that, the next positive cycle should be there. And here we don't have anything. And again, the next positive cycle should be there. That's what we have received from previous one without having capacity. But what will happen when we have a capacity? Can you imagine what will happen? Okay, during this positive half cycle, the capacitor will be charged. Okay. After that, the input voltage is coming to 0. But now at the moment, capacitor has been charged to this voltage. Now, the input voltage is going down to 0, but capacitor is having certain voltage. Then during this time, capacitor can provide voltage to the resistor. Okay, capacitor can provide voltage to resistor, but again, providing voltage to the resistor means capacitor is losing its charge. Then again, its voltage is also decreasing, but not like the input voltage, right? It's slowly decreasing, providing voltage to the resistor. It's going to decay. And during that time, again, the positive input voltage is coming. Then after that, it can be charged. Capacitor can be charged while providing the voltage to the resistor. After that, up to this point, again, input voltage is going down, but again, capacitor can provide supply to the voltage to the resistor. Then it goes like this. Now, when you compare the previous voltage, like this, only positive half cycles are there. During the negative half cycle, we don't have any voltage, output voltage is 0. But after adding this capacitor, what has happened? And during the blank period, we have certain voltage. But compared to the previous voltage, is a huge ripple is there. But now ripple has been reduced. Okay. And there is no blank voltage period here. All the time certain voltage value is there, but again we have a ripple, but compared to previous one, ripple has been reduced. Okay. Then what can we do here? By increasing capacitance. If we increase the capacitance of the capacitor, what will happen? It can charge more, it can collect more charges, and it can provide more voltages to this resistor. And if you increase this resistance, then the slope will be reduced. Then when you increase the capacitor, sometimes the slope will be reduced like this. But we cannot increase capacitor to much more higher levels. Why? Because the input side, we have to consider this input side also. So how we can charge this capacitor? We have to take current from the input side. But if you put much more large capacitor there, then it will take much more higher currents from the input side. The input is not capable enough to provide this current to the supply. The input side will be damaged. Because capacitor is expecting, capacitor is drawing more higher current from the input side. Input is not possible to provide this one. It's not capable enough to provide that one. Because of that, input side will be damaged. Then it's some kind of compromising between this ripple and the capacitance value, and we can have some kind of higher capacitor value, but understanding that how much of current input side can provide. The secondary coil can provide how much of current to the resistor at the same time to capacitor. But anyway, that you can see that if you lower the capacitance, we will have much more ripples, and if we increase the capacitance, the ripple will be reduced. Okay, then ripple voltage means this one. Sorry, if you put capital R, it may be another confusion. Then we can put simple R. Ripple voltage VR can be reduced if we increase capacitance. But we have to remember that much more large capacitors we cannot include without considering the input capability of the input side. Okay, this is the story for half wave rectifier. What about the full wave rectifier? Full wave rectifier situation is much more better than half wave one. We'll take this one. And when you put this capacitor, this one, we can take this circuit. So this full wave rectifier circuit, we can introduce this capacitor. This one also here also. This capacitor. Then let's try to understand what will happen. And we can take this waveform. Okay. Here, what do we expect? During the positive half cycle also, we'll have this voltage. This is what we are receiving without having capacitor. But now we have a capacitor. Because of that, the situation is much more better than the previous one. Now capacitor can charge up to this level and it can provide voltage to resistor. And it can go like this. But during that time, before the previous one also, that voltage is coming from the input side and it goes like that. Okay, with compared to previous one, you can see this is the ripple voltage. Ripple voltage has been already reduced because of the full wave rectification, and we have that advantage. But anyway that we have ripple voltage, here also we can reduce the ripple voltage there. By increasing the capacitance. Again, we have to think about the input side capability, how it can provide current to the input, the rest of the circuit. And considering that one, we can determine the capacitance value. Then anyway that with compared to half wave rectification one, the full wave rectification is much more better. So these are the things that we have to discuss with our applications. Now you know how to make PN junction, and around the PN junction we have depletion layer. you know how to break that depletion layer providing voltage. If it is silicon, that we have to provide 0.7 volts to break that one. After that, diode can conduct. We say it's forward bias mode. If you reverse the polarity, we say it's a reverse bias mode. During the reverse bias mode, diode cannot conduct. You can consider diode as switched off. During the forward bias mode, you can consider diode as forward bias. You can consider it as turn on diode. Okay. Then first application is we can use this diode as a switch. Various things we can do with that one. You can have some kind of protection circuits also. This diode switch application, I draw that one maybe a couple of minutes time. After that, the second application is rectification. Okay. When it comes to rectification, we have two methods for rectification: half-wave rectification methods and full-wave rectification methods. With the half-wave full rectification, we don't receive negative half cycle to the output side. It's 50% reduction, 50% loss we have. It's not a good method, but we compared to the previous one, we need here only single diode. It's a very simple circuit. Then when it comes to the full wave rectification method, we need 4 diodes. Diode bridge should be there. Compared to previous one, circuit is not simple, but again, it's a simple circuit having only 4 diodes there. With that, we have huge advantage. We can take that all the negative positive cycles to the output side. Then that loss is not there. Okay. But here you have to understand that during the positive half cycle and during the negative half cycle, which diode are operating and which are not operating. And you should be able to explain this operation. Then which diodes are forward bias and which diode are reverse bias, like that. You should be able to explain this operation. Then after that, we can do this half a full wave rectification. But anyway, here, this transformer side is not necessary all the time. But I have included this transformer side to understand you and how can we provide this voltage. That's only. Then again, these voltage, input side voltages are not smooth. Ripple voltage, higher ripple voltage is there. We have to have smoothing mechanism. The simple smoothing mechanism is adding a capacitor. Okay. Adding this capacitor, you can see compared to the previous one, we can reduce ripple voltage, but even that half-wave rectification method, we have much more ripple. Ripple can be reduced by increasing the capacitors, but it's again compromisation between that input side current capability and that capacitor value. Then when it comes to this full wave rectification method, and we have much more better waveform than half-wave rectification one. Again, here also, we can reduce the ripple voltage by increasing the capacity. Okay, that's what all we have discussed so far. Any question from these sections? diode applications, actually many useful circuits we can have. For example, assume that this is your electronic device. Okay, it's having input terminals like this. This is positive input terminal, positive voltage you have to provide. This is 0 volts terminal. And this is your battery, maybe the power supply, whatever the thing. Okay. It has this positive voltage terminal and 0 voltage terminal. And you can include a diode here. You can include a diode here in front of your circuit. Then after that, these are the new input points to your electronic circuit. Now you can provide these connections to the supply. Like this, and there is no harm to the circuit. Assume that you have connected like this, but these are the additional part we have included to your circuit. The additional circuitry we have added to your electronic circuit. So only simple diode. Okay, but the advantage of having this is that now in this way there is no problem. The current can go there, and your device is working. Okay. What about that if you reverse the polarity without knowing that the polarity of your device? What will happen if you reverse the polarity of the circuit? Without having this diode, it will be damaged. But in this case, assume that you haven't done this way. You have provided this positive connection to this terminal and negative connection to the positive terminal. And if you do it normally without having this diode, your device will be damaged. But in this case, there is no current going through this path. Why? You have put a diode. Diode should be forward bias, but in this case, diode will be reverse bias. Because of that, the reverse polarity will not be applied to your device. Okay, then here, the correct polarity. Correct polarity and correct voltage. Correct voltage has been applied to a device. But here, incorrect polarity, then device is okay. But this is incorrect polarity. During this time, this diode is forward bias, but during this time, the diode is reverse bias. Incorrect polarity. No voltage to the device. Still, device is okay. Why device is not working? But it's okay. It will not be damaged. Okay, any question? Anything? Is there another, the common application is a very another useful application, and even that you also can make this small circuit only single diode. Before you apply your supply terminal to the device, then you can include that single diode. You have to have small wires and other things. But anyway, that when you do this one, that it is not necessary to consider about the reversing the polarity. Okay, any question regarding this or maybe anything? Okay, if you don't have any question, that we can conclude the session. I'll discuss with Chamath that the dates we'll have the classes, other than that the next Saturday and Sunday and all these things, and during the weekdays also we can try to do something. Then to finish this one quickly, I'll discuss with Chamath and let you know. Okay, if you don't have any other question, we can wind up the class. We can finish the session. Thank you very much for your participation, and have a good week. Thank you very much.
Thank you, sir.